kiddos, we're going to move on to the next example here. This is example 9. Now, example number 9 is going to be, so what we're doing here is determine the value of k oh, there we go. Determine the value of k such that the graph of the function passes through the given point. I'm going to misspell through. And the function is f of x is equal to 20 e to the negative k x, and the point that we're looking at is going to be, it has to go through point 350 right there. And I'm going to need somebody to get ready with a calculator as well for this problem. Alright, so this problem here, example number 9, I chose this one because it combines two of the things we've already done before. We already know how to solve for different variables in our function given a point that we're crossing through. But in this case, we actually have that point, or the variable that we're interested in, the k, is in the exponent also. So this one's not as straightforward as the last one was. So we're going to do the exact same thing. We know that this part, the y, this is our f of x, and this part here is our x value. So I can go ahead and just fill it in now. I'm going to say that 50 is equal to 20 e. I do not know what negative k is, but I do know that x is 3. So what's going to happen from here? Yeah, I must isolate this part here. This guy here we must isolate. So that means we're going to do some division. And we're going to end up with 5 over 2 is equal to e to the negative 3k. Is anybody bothered by the fact that I put negative 3k here? No, right? All I did was I switched the order, so it's not that big a deal. To keep it in a fraction form? It doesn't really matter, to be honest with you. I just don't have a calculator here handy with me, so I'm just leave everything in terms of fractions and square roots. So at this point, we have to ask ourselves a question. Okay, where is the variable that I want? It's in the exponent, yeah. So if it's in the exponent, then what are we going to do to the entire function? Yeah, we're going to log both sides of it. Now, what's the smarter log to use, the common or the natural? Why? Yeah, you got an e in there, so then what we want to do is we want to take the natural log of both sides. So take ln of both sides. Dot, dot, dot. So I'm going to go ln of 5 over 2. That's just a number, right? The natural log of 5 over 2 gives us a number. Is equal to ln, it's not a secret number, ln of e to the negative 3k power. Now, what happens to our exponent? Because we've taken a natural log, that exponent is going to jump out. So the exponent travels out. So we're going to be left with ln on this side of 5 over 2, which is just a number, equals negative 3k ln of e. Ln of e is just equal to 1, so I can rewrite this as ln of 5 over 2 is equal to negative 3k. So to solve for k, we're going to divide by 3, and we're going to wind up with ln of 5 over 2 divided by 3. Oh, let's call it negative 3. is equal to k. Can somebody tell me what that approximation is? Negative 0.3054 is equal to k. All right. Okay, we got one more example to work through. I know it's kind of grueling. We got one more example to work through, and then I will